Okay, so today we are going to be doing things a little bit differently than we have in the past, and that's because I'm working from the home office. Yay! I wanted to do I wanted to do just a quick review of what we have so far. We've been looking at enthalpy or delta H. We've been looking at entropy or delta S. And we've been looking at Gibbs free energy delta G. All of these are how we have been calculating those different energy types for a reaction. And in the case of enthalpy delta H, we were able to calculate a delta H from calorimetry, doing things experimentally. So going into the lab and actually measuring how much water has heated up or cooled down or whatever. We can use an approximation using bond energies, which is not going to be as accurate as some of the other methods. We can also use heats of formation, and that is a matter of taking a look in Appendix G and doing products minus reactants. And we can do it using Hess's law, which basically requires that you have some other reactions that you can essentially add together in order to form the delta H of the reaction of interest. We then went to entropy and delta S, and the only way that we really did a calculation of how to come up with the delta S of reaction was looking in Appendix G and getting the entropy values for the products and the reactants and doing products minus reactants. For delta G, we came up with three ways. The first was using the equation that delta G is equal to delta H minus T delta S. And yes, I could have those superscript zeros on there and subscripts of reactions and all that kind of thing. I didn't have the space on my iPad to be able to do that. But yes, they could be under standard conditions. They could not be at standard conditions. It doesn't really matter. We can also get delta G from delta G of formation, just like we did with delta H of formation. And then lastly, we can use Hess's law. Again, you have to be given equations and their delta G values in order to come up with the delta G of reaction.